Hi everyone, thank you for joining us today. My name is Haley Deshane and I'm the events coordinator here at Eco Canada. Welcome to the Empowering Indigenous Communities, Introducing the Energy Code Compliance, Monitoring and Enforcement Toolkit Part 2 webinar. Before we start, I would like to take a moment to recognize the traditional Indigenous lands where Eco Canada's office is based in Calgary. At Eco Canada, we're committed to working towards respectful acknowledgement, collaboration, and reconciliation with Indigenous peoples across Canada. This starts with acknowledging our honor and privilege to live and work within the Treaty 7 territory. Today we are presenting from the City of Calgary, home to the Métis Nation of Alberta, Districts 5 and 6. We would also like to take this time to acknowledge the traditional territories and oral practices of the Niitsitapi home of the Blackfoot Confederacy, which includes the Siksika, the Piikani, the Kainai First Nations, the Tsuut'ina, the Goodstoney, which include the Chiniki, Bearspaw, and Wesley First Nations. I also want to go over a few housekeeping guidelines for today's session to ensure that everyone can enjoy and participate in the session effectively. All participants are muted, so please check your audio settings to ensure that you can hear us properly. If you are experiencing any technical issues, please use the chat function on the left-hand side of your screen, and we can do our best to resolve it for you. Today's webinar is being recorded and will be available for your viewing in 24 hours. Any questions that you have about the presentation or today's topic can be submitted through the question box. We will have a dedicated time during the presentation to answer any questions from the audience. Finally, we want to know what you think about our webinars and how we can keep improving. You'll be sent a short survey after the webinar ends. Please let us know what you think or if you have any comments or suggestions about the webinar. Eco Canada's vision is to build the world's leading environmental workforce. Eco Canada seeks to help environmental workers succeed at each step of their career journey. To do this, Eco Canada has developed programs tailored to individuals at different stages of their career. Eco Canada also provides opportunities for new workers to break into the environmental sector through wage funding for co-op students and recent post-secondary graduates. For those already employed as environmental workers, Eco Canada provides the environmental professional and environmental professional in training certifications and EPT students. Lastly, Eco Canada provides opportunities for those with vast experience as environmental workers to provide guidance and direction to Eco Canada's products and programs through advisory committees and emeritus memberships. Now I will pass it on to our speaker, Adam Trovato.
Thank you, Haley, and thanks everyone for joining us today. I am just going to share my screen with you here, so bear with me. Screen two. Okay, looks like that worked. Perfect. Okay, good morning, everyone, and thanks again for joining us today. As mentioned, my name is Adam Trovato, and I'm a principal at Simplify Energy Consultants. And today I'll be presenting on the Energy Code Compliance, Monitoring, and Enforcement Toolkit that Simplify Energy, Decarb Inc., and Eco Canada developed together. We already had a webinar that goes over the entire toolkit's architecture. So today's presentation is focused more on the National Energy Code. So we'll be going into a little bit more depth into that topic. We had to select what to present on here, so we tried to keep it very informative about the NECB, and there's a lot of different things that can be done with it depending on where your community is at in terms of whether you're looking to learn more about how to adopt building code or how to comply with existing building code. So as a result of that, we tried to keep the information pretty informative and focused rather than giving specific instructions on how to adopt building code. We kept it more informative at a detailed level. So my portion of the webinar should run around 45 minutes. And if at any point anyone has any questions, comments, or anything like that, please put them in the chat box and we'll respond during the Q&A session. In terms of the agenda today, we'll start things off with a brief introduction to myself and the project, jump right into the toolkit overview, and then get right into discussing National Energy Code. We'll start by going into the highlights of the NECB, and then a guide on navigating it, and then dive into NECB for housing and small buildings, and then we'll go into that Q&A session at the end. So I'll try and be relatively brief here, but yeah, so my name's Adam. As I mentioned, I'm a principal at Simplify Energy, and I'm a certified energy manager and technologist. I promise I'm not trying to brag. I'm just trying to make sure that you don't turn off the webinar. So at Simplify Energy, we are energy efficiency and sustainability consultants who work to provide building owners guidance on how to save money on utilities, reduce the environmental impact of their buildings, and make their buildings portfolio more efficient, higher performing, and align with their broader organizational goals. So as a result of that, we interact quite a bit with the building code, and really, while we try and help buildings get more efficient, often what we're trying to do is identify ways for them to get their building up to code as well. We provide energy audits, community energy plans, energy modeling, renewable energy analysis, funding support, and we've had the privilege of working to develop over $50 million worth of energy efficiency projects in consulting, construction, and program delivery. Particular to today's webinar, I've spent a great deal of my career working with Indigenous communities, having worked with over 30 communities throughout Alberta, BC, the Yukon, and Saskatchewan, and have worked on some pretty unique projects such as deep energy retrofits, clean transit projects, renewable energy development, and more. I've been lucky enough to see many of these projects from start to finish, and therefore have gathered some serious insights into some of the pitfalls to avoid in a construction project, as well as lots of the successes and failures that myself and the people I've worked with have been able to learn from. So this slide is a bit of a review for those who attended the last webinar, but I do think it's valuable context. This project was started in November 2024 when Eco Canada reached out looking for the development of a lasting toolkit for Indigenous communities that introduces both National Building Code and the National Energy Code of Canada for buildings. The toolkit was intended to explain the codes in depth, provide tools to communities to increase the adoption of building code, educate users on building science, increase energy and building literacy, and provide case studies, examples, and tools to further educate users. Simplify Energy and Decarb Inc. partnered up to develop this toolkit. And before I dive too much into the content, I would like to acknowledge the leader of this project, Ward Wilgar of Decarb Inc., who worked very tirelessly on this project. I think by the end there's about 80 or so versions, and his dedication to detail and high standards really stands out in this document. So I would like to acknowledge Ward because I'm very lucky to have partnered with him on this project and really believe that this is a very impactful document. I'd also like to thank the folks at Eco Canada. Pooja and her team really guided us on this and was providing continual feedback to make sure that this toolkit provides as much value to the community as possible. So as you can see from the chapter titles on the screen, the toolkit covers a large range of topics with a central focus on National Building Code, NECB, and general building science. Today, we're going to be covering these bold chapters. So the National Energy Code of Canada for Buildings, 2020, a guide to navigating NECB, and housing in small buildings, introduction to NECB for small buildings. As you can see from the table of contents image, Each section covers a wide range of content, and there's no lack of detail or content within this toolkit. So today we are going to focus on a few sections in a bit more detail, but rather than going through the actual toolkit this time, we're going to work off a PowerPoint that draws some of the key points from the toolkit. I went with a cat for this image this time. Last time there was a golden retriever, but I didn't want to offend any cat owners, so let's dive in here. Okay, so this morning I'll be providing an overview of the National Energy Codes of Canada for buildings, as you've heard me refer to it as NECB. These codes play a vital role in shaping how we design and construct new buildings across the country. At its heart, the NECB has two primary goals: to significantly improve the energy efficiency of buildings in Canada, and as a direct result of that, to reduce our overall greenhouse gas emissions. This is crucial for both our economic and environmental well-being and helps us align with some environmental targets that our government has set. The NECB produces minimum energy efficiency standards for the construction of buildings and is a model code for the provinces and territories to adopt, implement, and enforce alongside other jurisdictions such as municipalities and Indigenous communities. We'll get more into the roles of government later, as that's a pretty critical point of the NECB. It covers key building systems, which we'll also spend some more time on later. And finally, the current edition is 2020, which is I've just mentioned to display the reality that it's a forever evolving code, and we're typically working off something that's been developed a few years ago, and it's just like an ongoing improvement cycle. Okay, so now that we've gone over, a general understanding of what the NECB is, it's good to look at the key areas that it focuses on. So I like to think of these as the main things that the code pays attention to when we're designing buildings and building energy efficient homes and community buildings. So understanding these areas can help us make informed decisions that respect both our traditions and our need for energy efficiency, so we can provide as much balance as we can between those two things. So first, we have building envelope performance. For those of you who don't know, this is like the skin of our building: the walls, roof, foundation, windows, doors, really anything that interacts with the outside. So when you walk around your house, pretty much anything you can touch from the outside is part of your building envelope. The NECB emphasizes good insulation to keep the warmth inside during the cold months and the heat out during the warmer times. It also looks at air tightness, making sure that there aren't too many gaps in the building where it can leak air in and out. And this is really critical for both, building comfort as well as using less energy for heating and cooling the building. Much like how traditional building methods often focused on using natural materials to regulate temperature, that's how the building envelope is meant to, manage the the outside conditions. Next is HVAC system efficiency. Excuse me. HVAC stands for heating, ventilation, and air conditioning. This section of the NECB sets standards for how efficient our furnaces, air conditioners, and ventilation systems need to be. Good ventilation is also critical for healthy indoor air quality, and choosing efficient systems means we use less energy to heat and cool our spaces and ensure good airflow, which is important for all of our well-being. Next, we have service water heating efficiency. This focuses on how efficiently we heat the water we use for washing, cooking, and other needs. So, most of us have a hot water tank. It's a typical example there. The NECB has guidelines for water heaters and how the water is distributed throughout a building. The NECB also looks at lighting power density and controls. So this means setting limits on how much electricity we use for our lighting, and encourages the use of efficient light fixtures like LEDs. We often see in new builds, LEDs are sort of the standard spec. This has been a highly adopted technology, But we do want to take it a step further often by promoting the use of controls like occupancy sensors, daylight sensors, and things that turn off the lights without necessarily someone coming on and hitting a switch, which reduces the reliance on human beings because we can all forget to turn off the lights and make sure that the buildings get shut down when they're not in use. Another important area is energy recovery ventilation. So you'll hear these called as ERVs or HRVs. These systems help bring fresh air into our buildings while also recovering some of the heat from the outgoing air in the winter or cooling in the summer. This improves air quality without wasting a lot of energy, and it's more or less a way for the building to kind of breathe efficiently, I would say. The NECB also includes requirements for the efficiency of equipment and appliances. This is refrigerators, washing machines, other service equipment. You'll hear a lot about Energy Star appliances. Those are typically appliances that have a higher energy performance and therefore align more with NECB. And more, the NECB is emphasizing renewable energy integration. So this looks at the potential of incorporating on-site renewable energy sources like solar or geothermal, wind in some cases, although quite rare that it's actually building integrated. And this can help us become more self-sufficient, reduce our reliance on traditional energy sources. Obviously, that saves us money, but also provides communities with energy independence and less of a reliance on, large fossil fuel companies as well as utility companies, if that's something that communities are looking to wean off. Excuse me. Lastly, commissioning is an important process of the NECB. It's like commissioning is basically like a checkup for our buildings. After, during, but mostly after construction. It's just making sure that everything's installed correctly and performing the way that it was designed. So if something's designed towards NECB requirements, the commissioning agent goes in and makes sure that the installation actually reflects that design so that we see the energy performance that we were anticipating. Okay, so now we know kind of what the NECB is trying to achieve, what building components it looks at. How do we actually show that our building is meeting these requirements? Right? We need to quantify that our building is meeting code. How does that happen? Well, there's more than one way to do that. Sort of like there's more than one way to get to the store for groceries. It's the same way here. There might be the fast way, the long scenic route, and the way that has the least traffic, right? This is the same. We've got pros and cons to each of these. And depending what your goal is and what the building is, you might consider different paths. One common route is called prescriptive path. So like the name suggests, very prescriptive, very much by the books. This is a direct approach. The NECB provides a clear checklist of specific things you need to do for different parts of your building. For example, it might say you need a certain level of insulation in your walls or windows with a specific energy rating or U value. It's straightforward, especially for smaller and simple projects. It's inexpensive relative to the others as you need to do less energy modeling and things like that. You just go down the list, make sure each component complies, and off you go. Another way to comply is through the trade-off path. This offers a bit more flexibility. Imagine if one part of your building doesn't quite meet one of those specific requirements on the checklist. With the trade-off path, you might be able to compensate for that by having a better performance in another area. For instance, you might use a slightly less insulation in one wall, but install an exceptionally energy efficient window to compensate for that. To use this path, you typically need to do some level of energy modeling to show that your proposed trade-offs still result in the overall energy performance that is as good or better than if you had followed the prescriptive checklist. And this sometimes can lead to more cost-effective solutions on the construction side while providing equal or greater energy efficiency. Finally, we have the performance path. This is the most flexible route, but also involves a deeper dive into the building. Instead of looking at individual components, you focus on the entire building's energy performance. You set an overall energy consumption target for the whole building, and then use energy modeling to demonstrate your design meets that target. Just gonna grab a sip of water here. This gives a lot of freedom to make trade-offs between different building systems. We could do the same trade-off as I just discussed, or you could have a less efficient lighting system and have a super efficient heating system, as long as the total energy use stays within the total allowed limit. So often in a new construction project, the energy modeler will be working with the different design consultants to feed the model different iterations to see the performance. So, the modeler might come back and say, hey, the design doesn't hit the energy target. We need to make some changes. And then the architect or the prime consultant might work with the other engineering groups to say, hey, can you get a more efficient HVAC system in? And then the energy modeler plugs that in and sees the result. He says, yeah, that helped, but we need to do a bit more. So then the architect goes to the building envelope consultant and says, we need to go to triple pane, or we need to do another layer of glazing. You model that, it spits out the energy performance. And basically it's an iterative process where you're modeling the building, and which impacts the design, and then eventually you have an energy efficient design that involves all the engineering disciplines to create an output. So you can see with that, there are different ways to get your building to comply to NECB, and the best path for any given project for your community or your buildings will really depend on your specific needs, the complexity of the building, the expertise you have available, and honestly, your budget. Now, the NECB isn't just one size fits all set of rules. It can have different levels of energy performance that builders can aim for. Think of these as stepping stones towards an even greater energy efficiency. The newest version of NECB introduces 4 progressive levels, each building upon the last. So the first tier is improved performance. This level goes a bit beyond the basic minimum requirements of NECB. It often involves making smart, cost-effective improvements to the building design and systems we use. Moving on, we have the second tier, energy or significant energy reduction. Reaching this level means achieving a much more substantial decrease in energy use compared to the base code. This requires typically much more planning, integrating different design strategies, and using, in general, higher performing technologies. It's not just about being creative and whatnot. It's usually now about, paying a little bit more upfront for a more efficient technology, or even integrating new emerging efficient technologies. Then we have tier 3, high performance buildings. This tier aims for very low energy buildings. To get here, builders often incorporate advanced building designs, highly efficient heating and cooling and electrical systems, and sometimes are starting to integrate renewable energy, such as solar PV and ground source heat pumps or air source heat pumps. These buildings are designed to use very little energy in the first place, but are still grid connected and have the ability to tap into the grid to use electricity and power and gas as needed. Finally, the highest level, net zero ready energy. This is a building designed to meet basically the highest level of energy efficiency. The idea is, with the addition of on-site renewables like solar, geo, air source heat pumps, like I mentioned, this building would generate as much energy as it consumes over a year, resulting in net zero annual energy use. So the major distinction here, you'll hear net zero, and often people think you're cut off from the utility grid. Typically, buildings don't do that in order to, ensure that they have access to as much power as they need, but also um, it doesn't require as much energy storage. So the goal here is to, overproduce electricity and power in the summer months, create a bit of a credit with the utility, and then tap into that typically in the winter months when there's less sun to generate the solar system. So on net, you're generating as much as the building consumes, but in any given month, you'll likely generate more or less than the building consumes. Now, it's important to understand who's involved in creating and promoting the NECB. And it's not just one entity or one government. Different levels of government play a role. So let's look at what the federal government does in this process. They do a lot. So first, the federal government through Natural Resources Canada, or NRCan, and the National Research Council of Canada, NRC, is primarily responsible for the development and publishing of the actual NECB document. Think of them as the main writers of the rules. They bring together experts and research to create a model code that can be used across the country. NRCan also conducts a lot of research and technical support. They do studies to develop tools and resources to help us understand energy efficiency in buildings better. This research helps us inform the NECB and provides valuable information for builders and designers. The federal government also sets the overall national strategy and goals for the country. They decide where Canada wants to be in terms of energy efficiency, and the NECB serves as a key tool to help the building sector work towards these national objectives. So think, our politicians go and they commit Canada to a large climate goal. We need to go back and start doing the math as to how we're going to achieve that. And a lot of the national carbon emissions are within the buildings we use. So NECB acts as one of the major mechanisms to try and bring those carbon reductions down. So finally, the federal government plays a role in encouraging national adoption. So while they don't directly enforce the building codes, that's usually done by the provinces and the territories, they strongly encourage everyone to adopt the latest versions of NECB, and this helps ensure that we're making consistent progress in energy efficiency across all of Canada. You'll see on the right that I've put a map of Canada showing different climate zones. These zones are incredibly critical because the energy efficiency needs of a building in a very cold climate, quite frankly, like parts of the north, will be completely different than milder parts of the country. So while the federal government develops the model code, the provinces and territories often adapt and implement it based on the specific climate zone's needs. So I'm in Alberta, and we follow the NECB with some potential regional adjustments to account for our specific climate. As you can see reflected in the climate zone map, we have 2, 3, 4. We have 4 climate zones in Alberta, so some flexibility has been implemented into our code. So in summary, while the federal government sets the foundation and provides the tools, the province and territories often take their model and make it work for specific regions. So it's a collaborative effort to improve how we build and use energy across our buildings in Canada. Okay, so now that we understand the federal government's role, let's take a look at the provincial and territorial governments. This is often where the rules become most relevant to our day-to-day building practices. First and foremost, each province and territory has the authority to adopt and adapt building codes within their jurisdiction. This means that while the federal government creates the model NECB, it's our own provincial governments that decide whether to adopt it, and if so, how it will be implemented. They can choose to adopt it fully, partially, or with specific changes to suit their local climate, energy sources, and priorities. When I talk about energy sources, it's just a bit of a side point, I guess. You know, we often look at where our energy comes from as a critical piece of how efficient our buildings are, how much our buildings emit, because different provinces have a different energy makeup. So in Alberta, we have a lot of natural gas in our grid. We used to have lots of coal in our grid, which is a dirtier fuel than hydro. So, places like Ontario and BC and Manitoba that are loaded up with hydro, you'll often see a push to electrify buildings, and that's transitioning the heating system to electric heat. That makes sense because they're moving essentially from natural gas to hydro, which creates a large net environmental impact without necessarily improving the efficiency or the expenses of the building. In Alberta, our efforts, we don't necessarily have a catch-all approach that we can easily implement like that because we're moving from gas to gas. If we go from heating, a natural gas fed furnace to an electric heating system, it's gas to gas either way. So typically it does change how provinces look at these things and how we actually operate. Now I need to refine where I was because that was completely off topic. But so yeah, because of this authority, the energy efficient provisions from the NECB are integrated into certain provinces' specific building code, which, as you can see on the map, there's several unique building codes that are provincially defined. So you can see there's BC, Alberta, Ontario, and Quebec have all taken on their own type versions of the building code, whereas the remaining provinces and territories look to be on NECB, or at least National Building Code. Our provincial and territorial governments are also responsible for enforcement and compliance. So this is a very important part. They set up the systems for making sure the buildings are actually built according to the energy efficiency rules. And this includes things like reviewing building permits, conducting inspections during construction to ensure everything is up to code, and other activities along those lines. Furthermore, these levels of government often help with the training and resources. They may help develop and provide educational materials, workshops, and other resources for building professionals like architects, builders, and contractors to help them understand and comply with the adopted energy codes. This is crucial for ensuring that everyone has the knowledge they need to build energy efficiently and to actually comply with the codes because, the government isn't building these buildings most of the time, it's industry. So there needs to be proactive discussion going on there and education. Finally, the provinces and territories may also implement their own incentive programs. These are programs designed to encourage builders and homeowners to go beyond the minimum energy code requirements and adopt even higher levels of energy efficiency. This could include things like rebates or grants or installing energy efficiency equipment directly. So we've seen some of those in Alberta. I know that they've been in other provinces, and they typically just help move the needle on energy performance. While the federal government provides the model, it's our provincial governments that then take the lead in deciding which rules apply here, how they're enforced, and what support is available. Okay, so finally, we will go over the role of municipal governments and how they're involved with NECB. At the local level, municipalities are often responsible for local enforcement. Through their building permit and inspection departments, they're typically the ones who handle the day-to-day enforcement of the provincial or territorial building codes, including the energy efficiency standards for all new construction within their boundaries. So when you're getting a permit and inspections here, I'm in Edmonton, I typically deal with the city of Edmonton. So municipal building Officials handle permitting and inspections. They review building plans and conduct on-site inspections to verify that buildings are being constructed in accordance with the applicable energy efficiency requirements. That is, in my case, the Alberta Building Code. They are the ones who ensure that what's on paper is being built correctly. It's a little bit different than the commissioning, but think of it as a third party who's going in and verifying that construction was built to the way that the design required. Beyond just enforcement, municipalities also have their own local sustainability initiatives. Cities and towns like Edmonton will have their own plans and initiatives that aim to encourage higher energy performance in the buildings within their communities. So you'll sometimes see, programs meant for homeowners, build business owners, but then the city also can do things like set their own energy standard for city-owned buildings. So typically you'll see municipalities try and lead the way and build their buildings to a higher standard, not only to be a great example, but also to showcase some of the emerging technologies and provide comfort to those who want to try out solar PV or heat pumps when they can go through city buildings and see them fully operational. Finally, our cities provide information and support to local builders and homeowners regarding building codes and energy efficiency. They might have resources available to help people understand the requirements and to find ways to build more energy efficiently. As you can see on the screen here, there are policy tools and resources developed specifically for achieving energy efficient buildings right here in Edmonton, showing the local government's commitment to the area. So yeah, in summary, the municipal government plays a very critical role in making sure that energy efficiency rules are followed on the ground, and by supporting the community and those who work within it to build more sustainably. So we've discussed federal, provincial, and municipal roles. Now it's important to understand the role of Indigenous communities in relation to building codes and energy efficiency within their jurisdictions. So there's a diverse and evolving area, and I'm not going to go too deep into the legality of things because that's not my expertise. But within First Nations, Métis, and Inuit communities, there are different jurisdictions and governance structures and treaties and whatnot that dictate some things. But overall, there's typically an elevated level of autonomy for communities to manage this process on their own or implement it on their own. So one key aspect is diverse implementation. So Indigenous governments implement building codes in varied ways. This can depend on their specific governance structures, like I mentioned, treaties, self-government agreements, and priorities. So, like I said, there's not a single approach across all Indigenous communities, and every Indigenous community tends to operate slightly differently with respect to this, in my experience. Many Indigenous nations have code authority, so they have the right and ability to develop and enforce their own building codes, which may differ from provincial and territorial codes. This allows them to create standards that better reflect their cultural values, traditional building practices, and specific community needs that might be different than a neighboring community or something like that. In some cases, Indigenous governments may adopt and adapt existing codes like NECB or provincial codes, but tailor them to their specific needs and priorities. So I've definitely seen communities that just comply and adopt the standard building code, partner with a neighboring municipality for permitting and things like that, and take it on like that. Whereas others want to make it more specific to their needs and develop more in-house the capabilities to manage that process. Treaty and self-governance agreements can significantly influence how building codes are applied on Indigenous lands. These agreements may outline specific processes and authorities related to the building standards and regulations. Indigenous governments often have a unique prioritizing needs, so they may emphasize specific building standards to address their community's unique housing, cultural, and sustainability needs. This could focus on using local materials, incorporating traditional knowledge, or even addressing specific environmental concerns, or building to a higher standard of climate resiliency due to increased risk of wildfire and smoke, for example. Collaboration is obviously very important here. Partnerships with other levels of government, federal, provincial, and municipal, can influence code implementation. These collaborations can help balance external standards with local requirements and ensure effective implementation. Finally, I believe capacity is very key. Effective code implementation relies on sufficient resources and technical capacity within Indigenous governments. This does include having trained building officials, access to technical expertise, and the necessary administrative structures. So, as you can see on the map, Indigenous communities throughout Canada are located everywhere, each with their own unique circumstances and government. So, we can see throughout, just like the picture with the different climate zones, but then this layer is also, different cultural governance themes too. So it does become complicated to try and put a one size fits all approach. And that's why there is this flexibility baked into the process. Okay, so now kind of returning to the main structure of the NECB to help us better understand how it's organized. The NECB is categorized into 3 divisions with several parts to each division. The first division is compliance, objectives, and functional statements, which I'll go into detail here on this slide. So jumping right into compliance, this section lays out the rules and processes for meeting the code requirements. Key things to understand here are mandatory requirements and applicable sections. So knowing the functional must-dos and which part of the code apply to your specific project. Documentation, submissions, and inspections. Understanding the necessary paperwork, how to submit it, and what to expect during those inspections. And common non-compliance and updates. So being aware of typical mistakes and staying informed about any changes to the code. The second part focuses on the objectives of NECB. These are the reasons behind the rules. So energy efficiency and reduced consumption. The main goal is to lower the amount of energy use in buildings. Sustainability and environmental benefits. Reducing energy use helps protect the environment by reducing greenhouse gas emissions. Long-term savings and policy alignment. Following the NECB can save money in the long run and aligns with broader energy efficiency policies. And finally, the third part deals with functional statements. This provides some flexibility in how we meet the objectives, understanding the intent and performance options, focusing on what the code aims to achieve, and exploring different ways to get there. Flexibility in design and equivalent performance, allowing for innovative designs and materials as long as they perform as well as prescriptive requirements. And alternate solutions and working with officials. So providing a process for proposing different ways to meet the code and discussing them with building officials. On the right, you'll see a table of contents from a version of the NECB. This gives you a glimpse in how the document is structured. So I won't go into too much detail there, but just give you a snapshot. So understanding this basic structure is a great first step in navigating the NECB. When you need to find a specific requirements, Division B is where you'll spend a lot of your time. Now, when we talk about actually building energy efficient homes in community buildings, Division B of the NECB is where we find a lot of specific instructions. Think of this as the practical guidebook that tells us exactly what we need to do for different parts of our buildings. Division B breaks down things into different parts, and each part focuses on a specific area. This makes it easier to find the rules that apply to the part of the building that you're working on. For example, part 4 is all about insulation. Given our cold winters here in Canada, this is a very important section. It tells us the required levels of insulation for our walls, roof, and foundations. And you'll often see something called an R value, which tells you how well a material can resist heat flow. The higher the R value, the better the insulation. Part 5 deals with windows and doors. I think we all know how critical those can be for heat loss. Um, like an R value, you'll often see a U value for windows, which once again represents basically the thermal efficiency of it. Then we have part 6, which covers heating, ventilation, and air conditioning systems, which you'll hear me call HVAC. This section has rules about how efficient our furnaces, ventilation systems, and whatnot work, keeping our indoor air quality high, keeping our buildings efficient. Part 7 focuses on surface water heating. I already chatted about that earlier. Part 8 looks at electric power systems and motors, focusing on using electricity efficiently for things like lighting and any motors that we might have in our building. And Part 9 calls out the Building Energy Performance Compliance Path. This outlines the specific rules you need to follow if you choose the more straightforward uh, checklist-based way of showing that your building meets the energy efficiency. Importantly for us here in Canada, there's something called Appendix A, Climatic Information for Building Design in Canada. It's a bit of a mouthful. While it's at the back of the code, it's really crucial. This section gives us detailed climatic information for different parts of Canada. The specific insulation levels and the types of windows we need depend on our local climate. So, someone up in high level Alberta will have different standards than someone in Victoria. So the main thing here to remember about Division B is that it really gives the detailed how-to on guiding buildings energy efficiently. It gives us specific numbers, requirements, and really the detailed information on where a building component needs to be. Finally, I won't go into it, but the final division is administrative provisions. I don't think it warrants its own slide, but it's there to outline the procedures for applying, interpreting, and enforcing building codes. Okay, so finally, we're going to get into energy efficiency for houses and small buildings. I only have about 10 minutes, so I'll probably zip through these ones quickly. So building on our understanding of the overall NECB structure, it is critical to understand how communities build their smaller homes and houses in smaller buildings, and what part of the code that requires. So that's section 936. This part of the NECB focuses specifically on the energy efficiency requirements for our homes and smaller buildings. So as you can see, section 936 of the NECB is the part of the code that provides these tailored requirements. So it's designed with the understanding that houses, duplexes, and smaller commercial buildings have different needs than big towers and massive industrial facilities. So the rules for 936 are specific for these types of buildings that you'll see in the image. The places where we live, gather, and conduct some of our community business will often be under 936, whereas the bigger buildings will fall under general NECB. So it's important to note that these larger complex buildings primarily fit under what's known as Part 3. And these larger buildings often have a more intricate systems that have way higher energy demands. So that's the reason for the difference in the code. Implementing the guidelines in NECB 936 is really a foundation for energy savings. By paying attention to these requirements during design and construction, we get to build homes and small buildings that are more comfortable year round and cost less to operate and are typically just better for everyone, from the owner all the way to the tenants often. Finally, this is a pretty critical point in my opinion. While the NECB is a national model code, we know it's not the law everywhere. The same goes for 936. The specific version of NECB that's in effect, or any amendments or changes to it, are decided and enforced by each province and territory across Canada. So while we're discussing the national framework of 936, the actual rules you'll need to follow for any given building project or that you might look to adopt will be more adopted at the local level. So 936 provides a valuable framework for building energy efficient homes and small buildings, and really understanding its principles help us comply to it. So diving into the big differences between Part 9 and Part 3, so big buildings or small buildings and big buildings. The first difference is scope. Part 9 is generally for buildings typically that are under three stories or less, and have a building area under 6,000 square meters or 600 square meters or around 6,000 square feet. Think of most homes, duplexes, smaller commercial and community buildings that fit there. Part 3, on the other hand, larger buildings, basically anything above those numbers. The compliance approach also differs quite significantly. For Part 9 buildings, there's often a greater emphasis on what we call prescriptive compliance. We know about what that is, whereas bigger buildings often go for a more performance-based approach, which means that, they might need to invest a little bit more in engineering and analysis, but on a smaller level, often the prescriptive approach is taken. The systems within the building also play a big role in the difference. As you can imagine, Part 3 buildings often have much more complex mechanical and electrical systems. Most of our houses have a single heating system, blows air through the building. They're pretty simple buildings in the grand scheme of things, which makes the flexibility a little less valuable. Documentation requirements also vary. For Part 3 buildings, demonstrating compliance often requires more extensive building documentation and, like I said, energy modeling. Finally, it's crucial to remember regional adaptation. I won't beat that anymore, but as much as it's created by Canada, it really does. You have to go through each level of government to make sure that, you're following the right level for your territory or your municipality. So, one thing kind of worth looking into a little bit more is the main ways to meet the energy efficiency requirements for our homes and small buildings under Part 9. So prescriptive compliance, the checklist approach. So 936, very much like what we were talking about earlier, has a prescriptive checklist, and you just go through and check the boxes. So a lot of new home builders just build their homes to make sure they comply with each of those standards, and the result is a pretty efficient building. One of the advantages of the prescriptive path is that it's very easy to understand and makes it for small local builders. It's not some complicated project where they need to do a bunch of energy modeling and this and that. They can just make sure the building is performing the way it needs to and can build a good solid building. Because of the focus on individual components, compliance can be achieved by simply meeting these requirements, and it becomes pretty straightforward. To give you an example, the code will say, hey, have R40 on this wall, and you just need to have R40 on that wall, and you check the box. So I probably don't have time to go through each of these, but this is very much similar to the part three. Um, these thermal envelope, windows and doors, space heating and cooling equipment, service water heating, ventilation, and lighting are all the main things that the 936 is going to look at. And yeah, it's basically the major components of the building. So when it comes to meeting the energy code, and I only have two more slides, so we're getting right to the end here. So when it comes to meeting the energy code, the approach to flexibility differs between Part 9, which covers the homes and small buildings, and Part 3 for larger structures. So for Part 9, the main route for compliance, like I said, is the prescriptive route. But typically, it's worth noting that Part 9 does have a performance compliance path. This allows for some trade-offs between, based on energy modeling, where you'll show the whole building meets the energy target. So typically, energy modeling is done in different softwares for Part 9 versus Part 3. You'll see, you'll hear HOT 2000 for the more basic buildings, then hear things like IES. Those are completely different costs. Like to do a HOT 2000 model on a home, it might be $500 to $1,000, whereas to complete an NECB model on a large building in IES, the industry standard can be anywhere between $10,000 and $30,000. So it is an expensive cost to go through that energy modeling. Okay, so how do we apply the rules of NECB 936 to our buildings across Canada? So here are some of the steps to keep in mind. First and foremost, please consult your local, provincial, territorial building code. While NECB is a national guide, the specific legally binding requirements for your homes and small buildings are in the building code adopted by your province or territory. This is going to be your primary reference. Second, understanding your climate zones. So, like I said, the building envelope requirements in northern, northwest BC, super humid, lots of rainy, is completely different than me here in Alberta. I'm going to need a building that keeps out the cold in the winter and doesn't really care too much about moisture as much. Whereas over there, it's a pure moisture game. So completely different builds, really need to understand the climate zone. Third, focus on the prescriptive path first. That's not a general, like a must do, but for most residential and small commercial projects, meeting the straightforward checklist style requirements outlined in 936 is a very common and easy way to achieve compliance. Fourth, seek qualified guidance. Lots of people know how to work in this space, whether it's energy advisors, builders, contractors. So if you're not familiar, it's always good to ask. And then explore available resources. So kind of like the last point, but there are available resources to educate and ensure that the buildings we're building comply with whatever code you're trying to hit. So by prioritizing these things, understanding your climate, starting with prescriptive path, you'll be really well equipped, I think, to navigate 936. Now, as you've seen, I can go on for days about this. So I'll wrap up now. I hope you found this educational and helpful. I know it's a little bit of a dry topic, so if you have any questions, please drop them in the Q&A. And if you'd like to contact me about anything, I'm happy to chat. My email and phone is up there. As well, Pooja from Eco Canada, she is managing this program. So if you'd like to get the toolkit, please reach out to her at her email. Okay, that's all for me.
Thanks, Adam. Just for the sake of time, we don't have a lot of time for Q&A, but please, if you have any questions, reach out to Adam or Pooja. I just shared their information in the chat, so you can easily copy and paste. But other than that, everyone, thanks for coming. Have a great day. Thank you so much again, Adam. and we'll see you next time. Stay tuned for upcoming webinars and events we have on our event calendar. Thanks so much, everyone.
Thank you.